Morning, everybody. I am here today so as to teach the topic known as set in mathematics for ordinary level. So when you say sets in mathematics, sets means a collection of objects in a group. When you collect object in a group, we call it as a set. So let's see the definition of a set. Set, by definition, as I said, set is a collection of objects in a group. For instance, when you have 12 plates, we call it you have one set of plates. So that we call it as a set of plates. So in mathematics, when you define a set is defined by or denoted by capital letter, suppose capital A, and we use a curly brackets to represent an element of a set. For example, this is a set A. We use a curly brackets to represent the element which are in a set A. So the element in a set A are represented by using a small letter, but the set represented by a capital letter. Suppose you have a set A which have element of A, B, C, and D. This is a set A, but this set it have an element of A, B, C, and D. We call it as A, B, C, and D are a member of a set A. So A is a member of a set A. Then B is a member of a set A. Then C is a member of a set A. And D is a member of a set A. This symbol means A is a member of a set A. So A belong in A, B belong in A, C belong in A, and D belong in A. So this A, B, C, and D are element of a set A. So this is a set. But we have types of set. We have, let us see the types of set. We have three main types of set. We have types of sets. The first type we got as a finite set. Simple definition: when you say a finite set is a set with an end. Is a set with an end. Is a set with an end. Suppose you have a set A, which have element of A, B, up to Z. Or you have set B, which have element 2, 4, 6, and 8. This is a set A, have element 8 up to Z, and this is set B, have element of 2, 4, 6, and 8. So this is a finite set because it have a first member and a last member. It have a first member and a last member. So we got this is a finite set. After seeing this type of set, let's see another type of set, which is known as infinite set. When you say infinite, means something with no end. Infinite set is a set with no end. Is a set with no end. No end. So this set have starting point but no end, have no ending point. Example, we have set A, which is 2, 4, 6 dash dash. This means a set of no end. For example, we have a set of B of 1, 2, 3 up to. This is a set with no end. So it has a starting number 2 but no the last time. This is an infinite set. Let us see another type of set. The third type of set is empty set. Empty set is a set with no element. It's a set with no element. For example, you have a set A. It contains a curly bracket only with no element. This is called as this is empty set. Another symbol of not empty set is an A is equal to cover. This is an empty set. So this is the set types of set. Let us see the ways of expressing a set. Set can be expressed in 3 ways: in roster form, in wording, and by formula. So, ways of expressing a set. The first way is by listing. Suppose we are given maybe a set A which contains an element of 2, 4, 6, 8. This is by listing. Another way is by word. By word means use a statement. For example, instead of writing this A contain element of 2, 4, 6 up to infinity, you can say A in curly brackets or even numbers. Third method, the third method of expressing a set is by formula. By formula. For example, you have a set A which contains element 2, 4, 6, and so on. So instead of writing element of set A contains element 2, 4, and 6, you can write in formula. You can say, instead of writing this, you can write that A is equal to curly brackets. Instead of writing this set A containing element 2, 4, 6, you can write that like this one. A contain X is equal to 2n, whereby n is equal to 1, 2, 3, and so on. So why is this? Because X is equal to n, this is a formula for this element. When you substitute 1 here, 2 times 1 you get 2. 2 times 2 you get 4. Then 2 times 3 you get 6, and so on. Are you together? So this is a formula. So this is a set way of expressing a set. Set operation. This is another subtopic in a set known as set operation. In a set, we have 2 operations. As we know, in mathematics we have 4 operations. We have addition operation, subtraction operation, multiplication operation, and division operation. But in set, we have 2 operations. The first operation known as the union operation, and the second one is the intersection operation. Let us see the first operation, which is known as the union operation. This is the first operation known as the union operation. So in the union operation, the symbol which I used in this operation is mu. This is a symbol to present the union operation. After C, this is a union operation. Let us see example. How to find the universal or union of a set. Suppose you are given 2 sets, maybe set A and set B. Suppose you are given set A, which contain an element of A, B, C, and D. And then you are given another set, which is set B, which contain an element of A, B, D, E, F, and G. This is 2 sets. We have set A containing element A, B, C, and D, and we have set B which contains element A, B, D, E, F, and G. When I say union of a set, we can say A union B is equal to, in brackets, means you collect this element of in set A and the element of set B together. When you collect the element of in set A and the element which are in set B together, means you get the value known as A union of B. Suppose if we have A and A, take one A. If you have B and B, take one B. If you have C, here there's no C, but you take C. Because in a union, all elements which are in set A or in set B must be found in this union of a set. So take C, then take D, take E, take F, and take G. So this is A union B. In a union set, all elements which are in set B and all elements which are in set A must be found in this set. Are we together? Okay. Let us see another operation known as intersection operation. Intersection operation. Intersection operation. This is another operation in a set. We use a symbol and. This is for intersection operation. In the intersection operation, we see the elements which are occur in both sets. We find the elements which occur in both sets. Suppose you have a set A, which contains elements A, B, C, and D. And we have another set, maybe P, which contains elements B, D, G, and Z. Suppose you have a set A contains element A, B, C, D, and we have set B containing element B, D, G, and Z. So to find the intersection of these two sets means we find the element which occurred in both sets. For example, when you say A intersection P, we find the element which occurred in both sets. Suppose we have A here we have no A. Here we have B and here we have B. So B is an element which occurred in both sets. So B. We find another element which occurred in both sets. C, here there's no C. There's D, there's D. So D also occurred in both sets. G is in this set P, but in set A there's no G. And Z, it is in set P, but in A there's no Z. So the element which occurred in both sets is B and D. This is A intersection P. So this is the intersection of set A and P. Are we together? Other types of set. As you remember, we have discussed the two types of set. So here we have another types of sets. We have a universal set. So set marked as new. This is a universal set. So the universal set is a set which contains all elements which are found in another set. For example, we have a universal set maybe contain element A, B, C, D, and E. This is a universal set. And also we have a set A which contains element A, B, and C. Also we have another set which is B which contains element of B and E. You see? If this is a set A containing element A, B, and C, and this is a set B which contains element B and E, and we have a universal set which contains element A, B, C, D, and E. The meaningful of the universal set is that the universal set is a set which contains all members which are in set A and in set B. So in set B we have element B and E, and in set A we have element B, A, B, and C. So if you see A, B, and C also found here, A, B, and C, and if you see in B, B and E also B and E also are in here. So this is a universal set for set A and set B. So the meaning for a universal set is that a universal set is a set which contains all members which are in another set. So this A and B is another set. This is a set of universal for A and B. Are we together? So universal set is a set which contains all members which are in another set. Another set is known as a complement set. Complement set. A complement set is a set which contains elements which are not found in that set. For example, when you have a set A containing an element A, B, and C, Also, you have a universal set which is A, B, C, D, and E. This is a universal set for this set A, because the elements which are in set A also found in a universal set. So this is a universal set for set A. So when I say complement of a set, if I am given set A, so A slash, it will be a complement of a set A. Complement of a set A. If I was given a set B, it will be B slash. If I given a set P, it will be P plus. Because here we have set A, that's why I'm like A slash, because the complement of a set A is A slash. So what is the meaning of A complement? A complement means the complement of a set A means it contains the element which are not found in a set A but are found in a universal. For example, here A complement it will be is equal to C. In A we have A, B, and C, but in universal set we have set A, we have element A. A complement here we find the element which are not found in a set A, we place here, but are found in universal. So in universal we have element A, B, C, D, and E. In A we have A, B, and C. So the element which are found in universal but are not found in set A is the element of the A complement. So here we have A, B, and C, and here we have A, B, and C, but D and E are not found here. So D and E are the complement of a set A. So the complement of a set A means the element which are not found in a set A but are found in a given universal set. That is the meaning of the complement of a set. Examples. Suppose you are given the question like this one. Question 1. You are given universal set contain an element 2, 4 up to 8, and set A contain element 2, 4 up to 6, and also we have set B which contain element 4, 6, and 8. Then you ask you to find A complement and B complement. Are we together? So we can say solution. You're given universal set 2, 4 up to 8, and you're given set A which contains 2, 4, and 6, and set B containing 4, 6, and 8. You're asked to find A complement and B complement. First of all, we'll summarize your data as given from our question, that a universal set it contains element 2, 4, 6, and 8 according to our question here. Then set A which is 2, 4, and 6. So first we find A complement. A complement means a set which contains elements which are not found in a set A but are found in a universal set. Here I've summarized the data. We have set A which contains an element of 2, 4, and 6, and the universal set which contains element 2, 4, 6, and 8. So to find A complement, we consider the elements which are not found in set A but are found in a universal set. In set A we have 2, 4, and 6, but in universal we have 2, 4, 6, and 8. So the number or the element which are not found in set A is only 8. So the value of A complement of a set is only 8. So the complement of a set A for this question is 8. So let us see for a B complement. For a B complement, we'll summarize the data of B. B, we have 4, 6, and 8. 4, 6, and 8. Then we are required to find the B complement. B complement, it will be is equal to, so in B complement, we write the element which are not found in a set B, but are found in a universal set. Are we together? So to find a complement of a set, we compare a given set with a universal set, not with another set. We cannot compare a set B and set A, but we compare a set B and a universal set. So to get a B complement, we compare the element which are found in set B and the element which are found in universal set. So if you see here, B, in B we have 4, 6 and 8. But in universal set we have 2, 4, 6 and 8. So which element are not found in this set B? The element which are not found in this set B is only 2. So 2 is the element which are not found in this set. So the B complement is only 2. So this is a value for a B complement and this is a value for an A complement. Yeah? Diagram. So Venn diagram is another case in a set. So Venn diagram, it is a diagram drawn like this one. This is a Venn diagram. So this box here, it represents a universal of a set. This is a universal for a set. But there is another cycle which are inscribed in this box. As I said, this box represents a universal set. So there is another cycle which are inscribed in this box here. So the cycle which are inscribed in this box, suppose you have a cycle 1 and cycle number 2, which this may represent A and this represent B. Means this is a set A and this is set B. So this cycle which are inscribed in this box is element, represents the set A and set B, and this box represents a universal. So in a universal, there are 2 sets which are found inside of it. Let's see an example. Maybe you have a universal set which contains element A, B, C, and D. Then you have a set A which have element A, B. And then you have another set which is set B which have element C only. So then you are asked to represent these sets in a Venn diagram. So the first step, you must draw the box which represent a universal of those 2 sets. So this it will be a box that represents a universal set. Means this is the first step. So then focus on the given set. You're given a set A which contains element A and B, and set B which is this one contains element of set C. If 2 sets are not contains element which are in common, means you can draw a cycle which are not intersect. So for example here we have set A containing element A and B, and set B containing element C. So you can draw 2 cycles which are not touch each other independently. For example, this is a cycle for a set A and this is a cycle for a set B. Then for element in a set A which is A and B, put A and B. Element A, B. And for element which are in a set B, put the element which are in a set B, which is C. So this is the 2 sets which contains elements which are not in common. That's why the cycle are not touched to each other. So after drawing the 2 cycles to present a set A and set B, then focus on the value or the element in a universal set. In a universal set, the element which are found in a universal set is A, B, C, and D. But here, you can see there's element A, B, and C. So, you can see there's one element lack, which is element D. So, this element D are not found either in A or in B. So, if this element D are not found in a set A, also this element D are not found in a set B, means found inside, outside of these 2 sets. So, if you consider this as a universal, you can see all elements A, B, C, and D are in a universal A, B, C, and D. And if you consider the set A, you can see the element A and B, A and B. And if you consider set B, you can see there is a C only. So this is a representation of these three sets in a Venn diagram. And let's see an example. Maybe you are given a universal set which contains elements 1, 2, 3, 4, 5, and 6. Then you have another set, which is set A, which contains an element 2, 3, 4, and 5. 2, 3, 4, and 5. Then, when you have another set, which is set B, which contains an element 1, 3, 4, and 6. 1, 3, 4, and 6. This is set A and this is set B. So to represent this set in a Venn diagram, first of all, draw a square box, like this one. This box represents a universal for a 2 set. So you can mark that this is a universal set. Then consider you are given a set A which contains element 2, 3, 4, and 5, and then you are given a set B which contains element 1, 3, 4, and 6. So we can focus on 2 sets. If the set contains elements which are in common, 2 cycles must intersect each other. If the element given in a set are not appear in both sets, the cycle does not intersect each other. So here we have a set A and set B. There is elements which are in common. We have 3 and 3. We have 4 and 4. So the element occur in both sets. So if we have element in common, the cycle will intersect like this one. Call this maybe a set A, and this may be a set B. The first step, we fill this element which intersect or occur in both sets. We have element number 3 and number 3. Put this, and we have 4 and 4 occur in both sets. Put 4, 3, 4. Then find out what element remained. In a set A, the element must be 2, 3, 4, and 5. So also already we have 3 and 4 here. Is this cycle? When you cycle around this cycle here, you can see we have 3 and 4 inside of this cycle. But in the set A, we have 2, 3, 4, and 5. So 2 elements remain, which is element number 2 and element number 5. So number 2 and number 5 are not appeared in this section, but are appeared in this space, 2, 5. So if you consider this set A, you can see there is a 2, 3, 4, and 5 in this cycle. Let us see, check for a set B. In a set B, we have number 3 and number 4 which intersect in both sets. But the element remaining is 1 and 6. Put 1 and 6 here. When you see in this cycle of set B, you can see we have element 1, 3, 4, and 6 as this 1, 3, 4, and 6. Then check out for a case of universal set. In a universal set, the set which must be found in this square box must be 1, 2, 3, 4, 5, and 6. So check the element. We have 1, 2, 3, 4, 5, and 6. There's no element out, because those elements which are found in the set also are found in a set A and set B. So there's no element which you can stand outside. That is how to present this set in a Venn diagram. Let us see example number 3. Maybe you are given a universal set which contains elements A, B, C, D, and E. This is a universal set. And you are given another set which is P, which contains element B and C. And you are given another set which contains element which is set Q, contains element C, B, and E. This is set. We have set P and set Q. And also we have a universal set. So to present these 3 sets in a Venn diagram, we start by drawing a square box like this one. This square box represents a universal of a set. After drawing the square box to represent the universal of a set, then we check either there is an intersection of the element in set P and in set Q. We see there is a C, there is a C. The intersection in element number C. So if there is an intersection in element C, means the cycle of set P and that of set Q will intersect. So the cycle will be like this way. This is the first cycle for set P, and this is the second cycle for a set Q. The cycle intersect at this point because there is a common element C, which are found in both sets. So at this point of intersection, we put the element which are found in both sets, means the intersection of P and Q. So we put C. C, it is in common in both sets. So put C here. After representing the intersection element, then check for the P set. In P, the element which must found in P is B and C. So the element remain is B. So put B here. So and when you cycle this cycle for a set P, you can see the element which are found inside of this cycle is B and C. B and C is also found in B and C. But in another set which is Q, the element which are found in set Q must be C, D, and E. So if already if you cycle this cycle here, cycle Q, you can see there's element C only. But the two elements remain, which is D and E. The element must be placed in this point, D, E. So if you cycle in this cycle Q, you can see there's a C, D, and E as this found here. C, D, and E. Also, check for the universal. Universal means this square box. In this square box, the element which must be found here is A, B, C, D, and E. But already here we have B, C, D, and E. The element which lack in the box is A. You see, there's no A. There's no A in P. Also, there's no A in Q. So A, it will stay outside of these two sets. A. If we check for the another element, we see there's no another element. So this is a representation of these three sets in a Venn diagram. Are we together? So this is the end of this topic for today. Thank you. There's another part known as the subset of a set. When I say subset, means how many sets can be produced from a given set. If you have a set A, so how many sets can be produced from that set? For example, let's see. For example, when you are given a set A, which contains element A, B, this is a set. So when I say subset, means how many sets can it be produced from this set A? For example, here, the set which can be produced from this set A, B, can be A. This is the first set. Can it be B? Can be A, B. Also, can it be empty set, also found in this set. So these are sets which can be produced from this set A. So if we see this is set A, also found in this set A. This is B, containing element B, also are found in. This is A, B, also originated from this set A. And this is empty set. Empty set must be found in a set. So this is a subset. This is a subset for a set A. But we have a formula to find a number of subset. Number of subset given by n. Number of subsets. Number of subsets. Number of subset is equal to 2 power n. This is a formula to find a number of subset. This is a formula to find the number of subset. Number of subset is equal to 2 power n. N, capital N represent a number of a subset. But small n, small letter n, represent the number of elements in a set. Numbers of elements in a set. So, in order to investigate how many subsets are in this set A, you calculate the number of elements which are found in set A. The number of elements which are found in this set A is 1, 2. We have 2, A and B. So the number of elements in set A is 2. To calculate the number of subset, capital letter N is equal to 2 power n. So now n is 2. Put 2. 2 power n is equal to 2 times 2, which is 4. So the number of subset for this set A is 4 subsets. As we count here, we have 1, 2, 3, and 4. So the number of subset already is 4 for a set which contains 2 elements. So for a set which contains 2 elements, the number of subset is 4. So as we count here, 1, 2, 3, 4. Let us see another example. maybe you are given a set P which contains elements A, B, and C. Then you're asked, maybe you're asked to list down the subset of this set. First of all, before listing down the element or the subset of this set, you must find how many subsets are in this set P. So how many sets? When I say subset, means a set which can be produced from this set P by using this formula. As we remember, capital letter N represents the number of subsets and small letter n represents the number of elements. From our set P, the number of elements 1, 2, 3. We have 3 elements. So small letter n, which is the number of elements in this set P, is 3. Then we are required to find the number of subset, which is n. So n is equal to 2 power n. Capital letter N is equal to 2 power small letter n. So substitute 2 power n, put 3. It will be 2 times 2 times 2. N is equal to 2 times 2 times 2, which is equal to 8. 2 times 2 get 4. Then 2 times 2, we have 8 subsets. So if we have 8 subsets here, means we are just to list maybe from P, which is A, B, and C. Start to list the subsets from here. P is equal to A, comma B, comma C. The number of subsets, the first subset is A, is the first element. The second one is B. The third one is C. We have A, comma B. We have B, comma C. We have A, B, C. We have empty set. Then we count 1, 2, 3, 4, 5, 6, 7. But we are supposed to have 8. We have A, we have B, we have C. Then we have AB, we have BC. Then you lack AC, AC. So this is a list of subsets which can be produced from this setting P. If you count, the number of subsets is 8. And also, here we have 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is a list of subsets, means a set which can be produced from this setting